My name is Gita Mohshizadeh from the Danish RailNet, Danish Rail Authorities, or called Banedanmark. I was hired in 2011 in order to define the client requirement for a new line which was going to be built in Denmark. At that time, all the documentation we got during the tender design, during the construction phase, and then at last delivery to our asset management, it was static documents like TIF files, like Excel sheets, no intelligence, no CAD files. Today, 5 or 6 years later, we are talking about implementing BIM in life cycle. So that's the story I want to share with you today. First of all, a little bit about the Danish RailNet. It is a state-owned enterprise under the Ministry of Transport and Building. We have 2,300 employees and investments of 1 billion euro annually. We use the investments in order to make some speed upgrades, some new lines, capacity expansions, and then a part of our railway is not electrified, so we have a contract which electrifies the rest of the lines, and then we have a completely new signaling system, which is being established in whole RailNet. One of the new lines was the new line between Copenhagen, which is the capital city of Denmark, and Ringsted, which is a hub for the railways. It is the first time in many years we make a new railway in Denmark. It is approximately 60 kilometers, dual track, electrified, high speed, 250 kilometers per hour. We have 4 tunnels, 88 bridges, and lots of earth to be dug. We go through 9 municipalities, lots of agreements with them, utility relocations, and lots of buildings to be expropriated. The only stop we have within these 60 kilometers is a new station, and then we have some platform works in both ends of the line. The time schedule for the project, we started in 2010 with the Construction Act, and then we have invited the Danish Queen in December 8, 2018 to open the rail. We have a budget around 1.4 billion euro. Today we are finished with construction works and preparatory works. We have laid the tracks. Tomorrow we have a test drive, actually, the first test drive of the whole line. And then the catenary and signaling systems, they're going to start now. We count on using the most of 2018 for test and commissioning. When we started the project, we had a vision. We wanted to construct a new line, a European and best-in-class, by purchasing in a competing market. We wanted to use the economy of scale and state-of-the-art technology. And how to do that? In many cases, we were first movers. It was the first high-speed line in Denmark. It was first time we used design and build contracts. First time we used contract after negotiation in that type of projects. And then it was the first time we required exchange and delivery of intelligent 3D models through all stages. We had 5 joint venture consultancy contracts to design these 60 kilometers. We used almost the most of the major consultancy companies in Denmark. You can see the logos down there. Out of these 5 joint venture consultancy contracts, we got 11 preliminary design in order to make a tender for 11 design and build contracts, and 9 detailed design for 9 general contracts. And then at last, the electrification contract and signaling contract, they took the material over to do their works. And as you can see here, many of the major contractors are involved in the project. So the challenge was, when you have all these different companies to deliver data to you, how are you going to manage that data? Are you going to ask them to work in a specific product? We didn't do that. We said, do what you're best at, but then use the standards we have defined in order to exchange the data. We made a CAD manual where we defined our standards. We made some automated processes for control the quality of the data delivered. We gathered all these data in our document management system, project-wise, made some intelligent models out of it, iModels. And then out of these informations, we were able to do all these different extraction of these models, making clash detection, making visualization, exporting to our GIS system, quantities, setting out data, drawing production. Everything was based on these models. Using this one source of data, we were able to do all these things, ensure the consistency between the models, ensure that the volumes were as they were to be defined. And then we used them for different purposes too. The alignment of the railways was the center of everything. Around this alignment, we defined the minimum infrastructure gauge, which gave us the possibility to have free passage for the trains. Around this gauge, all the models were defined for utilities, for structures, for different type of structures, earthworks, and then when we gather all these models together, then we are able to make any kind of analysis. One of them is to generate the drawings, make sections and generate the drawings from the 3D models. And use the same models as well for making visualizations. A challenge is complying with time and budget in that type of projects. Having these 3D models, our contractors were able to make some simulation of the building process and optimize their processes. The picture below is from one of our contractors. This is a railway bridge. Above, you see the same railway bridge, but it is a kind of visualization of the building process in order to give some information to the different parts of the project. And at last, when you have these 3D models, you can, of course, visualize the final project. Another challenge is documentation of quantities. Having the 3D models, it is possible to make any kind of calculation and comparing the volumes. Another way to use the 3D models is how do you relocate all these earthworks. And the visualization here is made by one of the contractors within the tendering process. The contractor didn't get the project, but that's what we got during the tendering, during the bidding process. Consistency control is one of the other challenges. Having all these 3D models, gather them together, you're able to make any kind of, analyze. This one is cross-section each 1 meter all through the line. And then you can check the consistency of the models. Another challenge in railway projects is to ensure safety and interoperability. Having these design and build contracts, it means that the contractors and the consultants working on this project, they were only working on civil works. So they didn't have any information about the different railway objects. So in order to get through the processes with our assessor, what we did was that we defined requirements for free passage of the trains. Based on these requirements, we made a 3D model of the minimum infrastructure gauge, and then using that, comparing with all the models we got from our consultants and contractors, we were able to generate clash reports. And the clash reports were used as documentation for free passage. So if we didn't register any clashes, then it was documentation enough to say there's enough room for the trains to go through. It's actually the first time this method is accepted by an independent assessor. One of the benefits we got out of these 3D models was for visualization, simple visualizations, in order to tell the bidders what they are going to build, and to authorities to tell them what is going to be built. Another benefit is information to other projects. We have our electrification, our signaling project. This animation shows the above picture shows the line from the driver's eye, and then the one below shows where in the line you are and what's the speed they are going with. And then we made laser scanning of these 60 kilometers all the time. And then what we use the laser scanning is that normally is to define a terrain model. But what we did use these scannings to was to make a kind of visualization. We developed a program which could convert the 3D models to point clouds. Putting the point clouds in point cloud, you have actually the visualization. And the case is that using rendering with point clouds, it is at least 10 to 20 times quicker to make animations. And then it gives a complete understanding of what we are going to do. The below picture shows the new station which is going to be built. We put all these models in 360 degrees video. So while the train runs from with the necessary speed, you can go around with the iPad and up and down and right and left, and then you can see the line from the different perspectives. This one is available on YouTube, and everyone with an iPad or iPhone can go through, or Android anyway. And then supervision and inspection using 3D models was one of the other things we developed. There's an app where we put all these 3D models in the app, and then it has a GPS, so you can take it on the site with you, and then you can explore the models. We have put some links on the models. In this situation, there's a bridge, and there are some a drawing, and you can just push the drawing on the iPad, and then you can see the information about the bridge. Then there's a data list, for instance, in this example, and you can see some more information about this bridge. What you're able to is now having the different views in the same model. So here you go through and find a pump and find the specifications about the pump. And then what you are able to do too is if there are any kind of object information in the models, then you can get them here in the same application. And then you are able to make some redlining, take some pictures or notes, and then put it on the model. And when you go back to the company, to the office, then you can use them to correct the models. We have got many positive response from the industry. Some of them are 3D reduces the risks and ensures the quality. It is an effective tool to manage the interfaces. And having seen the models in 3D, actually, you can't do it another way. Using 3D models for tender means more clarified tender documents, which means reduction in risks. Reduction in risks means closer prices within the offers, and then it means that actually you're able to compete on solutions and not only on prices. 95% of all our contracts are signed totally 9.3% lower than estimated. We are on time, and we have extended our reserved budget from 10 to 15%. And all the experiences we have done, it has had a huge impact on the whole industry. We have now a collaboration between the major actors in the industry with the Danish rail and road authorities, association of consultancies and contractors, as well as the clients for the Femern Belt, which is the tunnel between Germany and Denmark. And together we are trying to define some standards for national standards for working with infrastructure projects. What we are doing in our organization is to find out, okay, now within the project organizations, we have all the processes, we have done lots of efforts, but it doesn't mean anything for a client organization if you are not able to use it in your operation and management organization. So that's what we are doing right now. The idea is that when you go through the different stages of the project, you enrich the data you have. So at last, when you deliver to your operation and management organization, they are able to use the same data for the different purposes. And then keep the data updated in order to, when you are defining a new project, then you have the most updated as-is situation as your basis data. When you are within a project organization, what you need is buildable and traceable project data. And use them for different purposes, for simulation, visualization, consistency control, or all these different processes which gives you the possibility to build the assets. But as soon as you are finished with that and deliver these rich information, rich data to your operation and management organization, what you need is to use them as the unique source of data. And then use these unique source of data for different purposes, which are needed in your operation and management organization. Financial management, initiating the renewal projects, planning your operation and maintenance, keeping them updated as is, and then archiving the documentation. So what we did as an impact of this project was that today we have 20 other projects in Banedanmark using the same standards, using the same working methods. We have defined a strategic project which is called the Digital Railway of Future. The mission of this project is to define the level of intelligence in our CAD models and define optimal data flow between the different asset management systems we have in Banedanmark. Transparency in our requirements when we say to our contractors or consultants that what type of as-built documentation is required. And then defining a logical object structure and classification system which applies to our needs in asset management. Reduction in redundant data, having so many different systems for our asset management. There are copies of copies of copies, to remove them, to have one source of data. And then use the 3D models during the whole life cycle. To do all that stuff, we need some preparation in our organization. That's what we have worked on in 2 years now. We are quite ahead, but then we need still to do some works. And we have a good collaboration with, within the Nordic countries with Sweden, Finland and Norway. We have BIM Nordic organization within the transportation organization, Rail and Road. And through these collaboration, we try to learn from each other, to use each other's results in the best way. We did it. We didn't have all these, documents on place. We didn't have classification systems. We didn't have all these things, which means that you can do the things, document what you are doing. We did it. But combining that with all the other efforts which is done within the Nordic country, then I think we have lots of success out of it. So I will thank you for your time.